Find the discriminant. This is a big idea in quadratics, and it wraps up our unit. Let's recap what you should have learned in the discriminant task you tried the other day. First of all, this is called the discriminant, b squared minus 4ac. That is the portion of the quadratic formula that is within or under the root sign. If the discriminant is greater than 0, in other words, if we have a positive number under the root sign, then there are two solutions to the quadratic equation. If the discriminant is equal to 0, that means in the quadratic formula, if we have a square root of 0, then there is one repeated solution. That means one solution that occurs twice. And finally, if the discriminant is less than 0, that means if it's a negative number, that means we have a negative under the root sign. Well, you know we cannot take a root of a negative number. Then there is no real solutions, but there are something called imaginary solutions. Let's take some notes. You're going to use the notes page that was provided to you. Here's the first sample. In this one, it says use the discriminants to find how many solutions, and then actually solve it to find those solutions. First of all, to apply the discriminant or to solve any quadratic, we need to have 0 on one side. So I'm going to move that 6 over to this side. By adding 6, that negative 14 turns to negative 8. Now let's apply the discriminant, b squared minus 4ac. B value is negative 8, so we have negative 8 squared, minus 4a value is negative 2, and c value is negative 8. So there's a discriminant. Negative 8 squared is 64, and all this multiplied, we have a negative, negative, negative. 3 negatives make a negative. It makes 64 also. Turns out we have 64 minus 64. That equals 0. So the discriminant is 0. And again, when a discriminant equals 0, we know there will be only one solution. So let's find that one solution. Here's that quadratic. I've rewritten it by factoring out to negative 2. Now, this part here turns out is a perfect square. It can factor into x plus 2 squared. That negative 2 can be divided away. Both sides, we're left with this. Then takes the square root on both sides. And finally solve for x. Notice we can only get one answer for x from this equation, and that matches what our discriminant told us. There will only be one solution, and there is only one solution to this quadratic. All right, let's see what this looks like on Desmos. All right, so here's that same quadratic right here. Here's the graph, and as we can see, there's only one x-intercept. That is the one solution, and it is negative 2. That graph only hits there one time there at the vertex. It hits the x-axis. Only one solution, and again, it matches our negative 2 that we found here. All right, let's try this one. On your page, you have the second one. See how you can do with this one. Find the discriminant value first, how many solutions, and then solve it. All right, let's check our work. First thing, I had to make 0 on the right side. I added 4x squared on this side. Negative 10x squared plus 4x squared makes negative 6x squared. Now we have our quadratic equals 0. Let's apply the discriminant. B squared, 12 squared, minus 4a is negative 6, and c is 18. 12 squared is 144. These multiplied make positive 432. Add those up, we have 576. That's the value of the discriminant. We know when the discriminant is a positive value, there are two solutions. Let's see if we can find those. You could use the quadratic formula to solve this, or I'm going to factor. So first I'll factor out the negative 6, comes out of all those, and I'm left with this. Don't need the negative 6 because there's a 0 here. If we divide by negative 6 on both sides, it'll cancel away. However, this also can be factored. This can be factored into x minus 3, x plus 1. Now I got rid of the negative 6. Now we have two factors here. Set each of them equal to 0, applying the null factor law and solve. So this one tells us x equals 3, this one tells us x equals negative 1. There's two different solutions, and that confirms what our discriminant told us, that there would be two solutions, and here they are. So let's check this one on decimals as well. So this is the second one. Graphed it now, it's graphed in blue. You can zoom in a little bit to see the vertex. Again, our two solutions were 3 and -1. So let's check. That means that the x-intercept should be 3 and -1. That's right, -1 and 3. So everything is working out so far. Let's look at the next one. This is taken from your assessment that you just had. After you discovered the discriminant rules, you had to try some problems. This was one of the 7-8 problems. Let's take a look. It says this quadratic equation has one repeated solution. That means the discriminant will be equal to 0, because when the discriminant is 0, then there's a one solution, or one repeated one. This one is written in a strange way, though. We have this n value and this n value, so that just means there's some unknown value there. So our job is to solve for n first. So let's begin with the discriminant. Well, first of all, a value is this number, n. B value is this one here, -6n is the thing in front of the x. And the c value is 45 right here. Putting that into the discriminant here, we put in the b value, -6n squared minus 4ac. A is n, and c is 45. So I've substituted into the discriminant. Now, -6n squared, you may think is -6n squared, but you have to actually square both of these. -6 squared is 36, n squared is n squared. So there's that first part. This multiplied, -4 times 45 is -180, and we have n equals 0. And solve this. This is a quadratic that can be factored. There is no c value, so we can just factor out a value here. So from this and this, I was able to factor out 36n, and I'm left with n minus 5. So 36n from here leaves an n, and 36n from this leaves -5. Now I have two factors equals 0. Applying the null factor law, 36n equals 0, n equals 0. Then we take n minus 5 equals to 0, and we solve that. We have two solutions. However, one of those values of n does not make sense, and that is n equals 0. Because if you put 0 back in here, this would no longer be a quadratic. So we ignore this n value, and we say n must be 5. So n must be 5 in here in order to have one repeated solution. Let's check. I put 5 in here, 5 in here for both n values, and I have 5x squared this, and then that can factor out of 5. This thing here factors, let's see, it's a perfect square. It factors like this. Then 5 can be divided away. This, if you take the square root, x minus 3 and x equals 3. So a single solution, which we noticed, that's how we set up this problem. We said, where does n have to be in order for this thing to have one solution? So we assumed one solution, found out what n has to be, plugged it in here, and we created this single quadratic that will have only one solution. Let's check that one on Desmos. So here was that one. I wrote it with the n value, right? And we just found out that n has to be 5 in order to have one solution. So right now, n is 4.2. And notice this thing, this quadratic does not even touch the x-axis, has no solutions. As I make n smaller, it rises up, no solutions, no solutions. But we found out when n equals 5, it will have one solution. Let's check. There, n is 5 now. Notice here, it has that one solution. And solution is x equals 3. And that's what we found here. That is x equals 3. Now when n, make n some other values. Let's see if I make n bigger. Now n is bigger. Now notice it has two solutions. So there's only one n value that produces that one solution, and it is n equals, let's go back again, n equals 5. That's the only way you can get there to be only one solution. And that's what we found out here. So now try this one the same way. Look for the single value of m that will give this quadratic only one solution, because there's only one m value that can make this have one solution. Any other m value, it will have two solutions or no solutions. So see if you can find it. All right, here we have A value is m, B value is 12m, C value is 108. Applying the discriminant, again, we were told that this must have one solution. So to get one solution, we set up the discriminant equal to 0, because that's when we have one solution. Plug in the values b squared minus 4a and c. 12m squared is 144m squared. This multiplied here makes 432m. You can factor out 144m here. And from this part, we get m equals 0. From this part, we get m equals 3. Again, m equals 0 is no good because it would make this a non-quadratic if this was 0. So m equals 3 is really our only possibility for m. So I substitute that m equals 3 in here. There's a 3, and the 3 in here makes 36. So there's that. There's our quadratic. This quadratic will have only one solution because that's the m value there that we figured out that would give one solution. So this should have one solution. Let's solve. Let's factor out 3. This is a perfect square, x plus 6. I got rid of the 3 already by dividing by 3. Solve it, x equals negative 6. Confirm that one as well. That's this one here. Here's a quadratic. Here's m equals 2.8. When I make m bigger, there, m equals 3. There's the one solution right there. Only when m equals 3, when m is bigger than that, there's 2 solutions. And when m is smaller, there's no solutions. All right, a couple more on the back of your page. We have this, find the value of r so that this has only one solution. Same kind of problem. The discriminant has to be made to 0. See if you can find the r value. Okay, substitute in negative 3 for b. That's negative 3. Negative minus 4a is r. See, this is actually easier than last question because r only appears once in here. Solve this. Let's see. We get 9 minus 36, r equals 0. When you solve that, you get r equals 9 over 36, or 1/4. Let's check that one. So here I have this right here. There's a quadratic. And we just found out r must be 1/4 in order to get one solution here. So we did this one solution thing. We found out r must be 1/4. So r, or in other words, the a value must be 1/4. But right now, the r value is 0.3. And we see this quadratic has no solutions. It doesn't touch the x-axis. Let's make this, as r gets bigger, look, no solutions. It goes up higher. As r gets smaller, it gets closer to the x-axis. Hey, look, I made r smaller than 1/4. 1/4 is what we need it to be. 1/4 is 0.25. This is no good. Notice there's 2 solutions. Let me change this again. There, exactly 1/4, 0.25, and notice there it is. I've made a single quadratic. A value has to be 1/4 in order for that quadratic to have only one solution. Any other r value, it has 2 solutions or no solutions. This problem is almost identical now, except notice it has the same equation, but it says find the value of r so that this thing has 2 unequal solutions. That means 2 solutions. So we're no longer looking for one solution, we're looking for 2. For this one, you can set it up this way, right? The discriminant, in order to have 2 solutions, the discriminant must be greater than 0, right? It must be a positive value. So it's the same setup of greater than 0. So here it is, 9 minus 36r. That's just the same as before. When you do b squared minus 4ac, it must be greater than 0. And if you solve that, you get r is less than this value. R is less than 1/4. So it's exactly like solving the other one, but now we're using inequalities. So you should be familiar with solving with inequalities. Let's check. So when r is less than 1/4, this thing will have 2 solutions. And I think we just saw that already. When r is less than 1/4, so if I go here, this is less than 1/4, it has 2 solutions right here. So this, see, r is still less than 1/4, and then r is 1/4, one solution, and r is greater than 1/4, no solutions. Everything makes sense. All right, good job. Please finish off the rest. There's more to practice.